Children, the next topic what we are going to learn is about salt hydrolysis. When a salt is formed, when an acid reacts with a base, a salt and water will be formed, and this reaction is called neutralization. Here, the salt and water, among the salt and water, salt get completely dissociated in aqueous solution to give their ions. The ions are hydrated in water. In certain cases, the cation and anion both react with water, and this reaction is called as salt hydrolysis. Now, there are four types: salts of strong acid and strong base, salts of strong base weak acid, salts of strong acid weak base, salts of weak acid and weak base. Now we are going to learn which one is acid, in which acid reacted, base reacted, and where there is hydrolysis takes place and where there is no hydrolysis takes place. We are going to see now. First we can take salts of strong acid and strong base. Strong acid example, you take nitric acid, HNO3, strong base, sodium hydroxide, and this giving a salt NaNO3 plus water. Here this is a salt and this is the water. The salt NaNO3 completely dissociated in water, giving Na plus NO3 in aqueous, completely dissociated in water. But water dissociates to a small extent. This arrow shows only partial dissociation, so the equilibrium exists between the dissociated and the undissociated. Here this means completely dissociated. So here, if H plus concentration equal to OH minus concentration means the solution is neutral, water is neutral. Here NO3, Na plus NO3 minus. The NO3 minus is the conjugate base of the strong acid HNO3, and it has no tendency to react with H plus. Similarly, Na plus is the conjugate acid of the strong base NaOH, and it also has no tendency to react with OH. So here there is no hydrolysis. In such a case, H plus concentration equal to OH minus concentration. So pH is maintained, the solution is neutral. Next, number 2, salts of strong base and weak acid. Strong base you take NaOH, weak acid you take CH3COOH, dissociated to give CH3COONA plus water, salt and water. Salt completely dissociated, so CH3COONA giving CH3COO minus plus Na plus. Here this CH3COO minus is the conjugate base of the weak acid, and it has a tendency to react with H plus to produce CH3COOH. So CH3COO minus reacts with H plus to give CH3COOH. H plus from water molecule giving CH3COOH plus OH minus. So here OH minus concentration greater than H plus concentration. So in these cases the solution is basic and the pH is greater than 7. Since it is a strong base, weak acid, base, OH is greater than H plus. Since it is a weak acid, H plus, so it is a basic solution having pH greater than 7. Now, third type, strong acid and weak base. Strong acid take HCl, weak base you take ammonium hydroxide, giving ammonium chloride plus water. This is the salt, acid, ammonium chloride completely get dissociated forming NH4 plus Cl minus. Now, this NH4 plus is the conjugate acid of the weak base. NH4, weak base NH4OH, and it has a tendency to react with OH minus. So, NH4 plus reacts with water to give NH4OH and remaining H plus. So here H plus concentration greater than OH minus concentration. So here pH is less than 7. The solution is acidic. Now fourth one, weak acid and weak base. Weak acid, let us consider the hydrolysis of weak salt of weak acid and weak base. Weak acid consider CH3COOH, giving weak acid CH3COOH and weak base ammonium hydroxide, giving CH3COONH4 plus water molecule, salt and water. Here salt, CH3COONH4 when treated with, it gets completely dissociated to CH3COO minus plus NH4 plus in aqueous. Now this CH3COO minus treated with water, giving CH3COOH plus OH minus. OH minus, since it is an acetate ion, it can react with H. Similarly, this one NH4 plus can react with water forming NH4OH plus H plus. Here having both OH and H, so here the nature of the acid here also gets neutral. H plus OH that is becomes equal. So if the solution depends on the strength of the acid means it is less than 7. If it is base, it means greater than 7. So if Ka equals to Kb, acid plus base, if the solution is neutral. Now we have found two neutral, strong acid, strong base, weak acid, weak base, we found neutral. Strong base, weak acid, we have said that it's basic, pH greater than 7. Strong acid, weak base, we have found pH less than 7, that is acidic. Now from the second one, that is strong base, weak acid, we are going to derive a relationship between the hydrolysis constant and dissociation constant. Here, for this one, we are going to derive a hydrolysis constant and dissociation constant in the next video.